So we have convergent, divergent. How many persons in here were absent on Monday?
Kiana, Logan.
Me,
Logan.
Sibella,
sir.
Kendra, Otis.
Okay,
Me.
Kiandra, Logan, and somebody named me. Spence?
Oh, somebody named me.
Yeah.
Kevin.
Okay, Kevonik, Tiana, and Kiandra were absent. Okay. All right, so
And Ortisa and Travis Mesaro.
okay. All right. All right, so I am going to send that recording. I'm going to start with that recording here. I'm going to start with that recording that you can look at. All right, so we have different types of sequence. So when I put the videos together, you'll see what the different types of sequence are. So this is from last class. So types of sequences: convergent, divergent, and guys, when I'm talking about sequence, I'm talking about a series of numbers. Like, you remember these things in CXE when you get some numbers and you have to find the missing one. Remember that?
Yes, sir.
Right. So if you're absent,
Yes, sir.
essentially that's the topic. What it's all about. But it's I kind of stepped it up a little bit, you know. Yeah, in terms of the knowledge base, step up a little bit. And we have different types of sequence. Convergent means it converges to a point. Diverge means that it just gets bigger and bigger. And periodic means that it it's a cycle. In other words, it's a cycle. All right. Well, I hope you ladies are not offended when I because I said period and it's a cycle. So all right. I don't know. All right. Okay. No, we have another type of sequence. It's called arithmetic sequence. All right. And then we have something called geometric sequence. All right. So I'm gonna spend a little time, well, not a whole lot of time, but just to explain what arithmetic sequence is all about. As a matter of fact, these are two separate topics by itself that we're going to look at in depth. But I'm not ready to go into depth with those two topics. All right, so arithmetic. Oh boy, what's happening here? Arithmetic sequence. So now we stop. Alright, you know what? Let me just leave it. Probably see it better that way. All right, so arithmetic sequence. Let me give an example of an arithmetic sequence. All right, so later on you realize that it's not called as arithmetic sequence. They call it arithmetic progression. An example would be like this. All right, so that's an example of an arithmetic sequence. All right. Question: even though it's called an arithmetic sequence, would you also say that this is a all right? True or false? This sequence is a finite sequence. True or false?
Sir, I would say, wait, sir, a finite, you say?
Yeah. Let me repeat myself. Is the sequence the sequence is a finite sequence? True or false?
Might be true.
I would say,
Okay, I'm not really hearing.
Say might be true.
It might.
false.
All right. Okay. It might be true. No, it's actually a false statement. What's a finite sequence, by the way? A finite sequence is a sequence that's
Start and
that's
stop.
a limit, not true. But if you look at this, what does this dot represent? Goes on, not true.
Continue. It goes on.
Right. Next question. True or false? This sequence is a divergent sequence.
True.
True. What does diverge mean? Larger. Larger, not true? Look at these numbers. They keep on what? Now, how do we know that what special property does an arithmetic sequence have? Right? This is a property. So let me you see this that one that is term one, not true? Term two.
Yes, sir. Term,
Right.
term 3.
Term three. That's term 4. Term 5. All right, so here we go. Suppose you see, I do something like this. I subtract. Suppose I subtract A5 subtract A4. What will I get? You get 3, not true?
3.
Yeah, why is that?
Yes, sir.
Suppose I
Yes, sir.
subtract A4 and A3. What would I get?
3.
3.
3 same way.
All right. And if you continue, you get the same thing, not true?
Yes, sir.
Right. So what you notice?
They all have a difference of 3.
Have a difference of 3. Very good. And that is how you identify. Right. So when we subtract, when we subtract, we get common difference of 3. All right. So in other words, so therefore, if the common difference is constant, then sequence is called a arithmetic sequence. Get that, guys? So when we subtract, we get what? A common difference of what? 3. All right. So therefore, if the common difference is constant, then the sequence is called an arithmetic sequence. So that's how you know what the sequence is called a what? Arithmetic sequence. When the common difference is the same. Everybody follow?
Yes, sir.
All right. Okay, so let's look at the other one. Other one is called a geometric sequence.
Sir. An example of a geometric. It could be like negative, right? Negative and then positive.
You mean geometric? No.
Yes, sir. Okay.
Okay. So let's look at what we call geometric sequence. Everybody have this? Can I move on?
Still writing.
I'm just write it down just in case. You guys still writing? Travis?
Sir. Finish.
All right, please look at set up for me geometric sequence. All right, now you see the geometric sequence. How do we know it is a geometric sequence? Well, apart from the fact that this is the sequence is also infinite, also divergent, not true, increasing, right? But this sequence is specifically called a geometric sequence because so what would we say? Well, in the arithmetic sequence, we subtracted the terms, that's true. to know, and when we subtract the terms, always get what? Same thing, not true? And that is called, and when we subtract it, it's called a common difference.
Yes, sir.
And if the common difference is constant, that doesn't change, then we know it is a what? Arithmetic sequence. Now, guess what now? You can subtract one of them, you know. Subtract about 3 of them here. Because sometimes you subtract 2, you get the same thing, you subtract one next one, and the number change. So you have to be very careful when you subtract it. But for the geometric sequence, what we do, we don't subtract. Alright? Oh, by the way, I need to mention something. When we're doing this this math, common difference is actually well, I say CD, but it actually is referred to as D in the text. All right, so D represents common difference. So you won't see CD here. You won't see CD. What you'll see is what? D. All right, so let me ask a question. If I were to divide if I were to divide A2 sorry about it, got weird. Okay. Hold on, guys. All right, guys, sorry about that. All right, now, what if I divide this, A2 by A3, A1, sorry, what would I get? That
2.
is 6. 6 divided by 2, not true? Sorry, not 2. 6 divided by 3, which is what?
And 2 as the answer.
Yeah. And what if I divide A3 by A2?
Sir, 2. You get it. Say you go say 12 divided by 6 give you 2.
Mm. Oh, you notice? If I continue like that, all of them would be what? 2.
Oh,
2.
That,
so sir.
Yes, sir.
right.
Sir, what would I do for this? I want to multiply by 2.
Oh man.
Just divide.
Right, think about it now. We're trying to identify what type of sequence it is. Follow?
Mm-hmm.
We're not working out any maths. We're not doing any math. We're just trying to identify. Let me tell you something. Let me tell you something. You see, in the exam, you might be given a question, and then they might not tell you what type of sequence it is. Follow what I'm saying?
Sir.
Right, and then they ask you what type of sequence, because there are various questions we can ask you. When we get into it, you're gonna realize that questions they can come really serious. So what I'm doing, we're just identifying geometric sequence and the arithmetic sequence. All right. So
Yes.
so and notice which one we divide by which one, true?
Mm-hmm.
Always the second one divided by the what? First one. Always the third one divided by the what? Second one. You need to make a note of that. Alright. Mute your mic for a minute, please. Notice when we're subtracting, always the previous one. So for example, this would have been A4 or A4 to be A4 subtract what? A3, A3 subtract A2, etc., etc. So in other words, don't start here. You don't say 1, you don't say A2 subtract A1. I'm sorry, you don't say A1 subtract A2. It's always the other way around. Or in other words, this number is always what? That one. Right? So let's get back to the geometric sequence. So when we divide, notice when we divide, not true. We divide terms, and if we get common, or it will be a common ratio. Restructure that. Divided terms. We get a ratio that common or constant and the sequence is called a what? Call it geometric. All right. So 2 is called, therefore, 2 in the above example called the common. Right? So 2 is called the what? Common ratio in a geometric sequence. But in an arithmetic sequence, the difference is called what? The common difference. That's how you differentiate between a arithmetic sequence and a geometric sequence. All right, class? All right.
Yes, sir.
You know, sir, I'm not gonna lie to you. You know, sir, if I was teaching this in class, I would done with this thing a long time ago. Some thing is just slow. Oh boy, this thing is really slow. I would have probably just mark off a little box and just scribble this thing down. Fast. So.
So to school now,
Huh? Yes, you know. Yes,
Or school not get picked.
I would want no. It didn't get picked in this batch, but I suspect it's going to open soon. And if and when it opens, only grade 10, 11, and 12 and 13 will be allowed to come back. You follow? And they're working on a time. They're working on a timetable. They're gonna change up the timetable for you guys. All right? Yeah. Although I like the times. You know, I like the times that they give us. I can sleep late Friday mornings. Friday morning is the only morning I have in class. Man. All right. Well, let us hope that one, that they open back school soon, provided it is safe to do so, because when we open back school and people take sick. Remember, if you have an underlying health problem, getting the COVID is very serious. For example, asthma. Can you imagine? I mean, the COVID virus attacks your lungs. So can you imagine if you have asthma and you get it? And you notice that the people are dying are elderly people who have underlying illnesses. So be careful. And if you as teachers at Greenpoint, we're adults, and we're young. And you have teachers that are ill too, have underlying health issues. And that's another thing too. That's a very tricky situation. And then when everybody knows everybody knows each other, everybody want to hook up everybody, and boom, virus starts spread. Not true. That's another thing. But so there you go. Anyways, let us look at some. Are you guys through with this? Are you through writing all this?
Yes, sir.
Yes, sir.
Alright.
Yes, sir.
Let us look at a question. And this is from last week, all right? From last week. So practice questions. Because some of you guys weren't here, I am going to do one for you. All right? So okay, so this one says write down. Hold on. Write down first 4 terms in the sequence. Find by. All right, so I have all right, so this is called what we call a recurrence relation. It would just say it's a formula. Basically, it's a real formula. So in other words, we want to use this formula basically to write out the series. Not series, sorry, the sequence. All right. All right. So let n equals 1, 2, 3, 4, etc. And you notice that we have an n here, not true? And the formula, not true? All right. So basically, so when n equals 1, we're going to get this. It's going to be a1, not true? That's how you go. See? That's
Yes, sir,
A1,
yes, sir.
right? A1, I'm using this, so it's going to be 3 subtract minus n is equal to 1. It will be 1 raised to the
1
what?
square.
Second power. And therefore we have 3 subtract. So we work inside the bracket first. And what is 1 square? 1, not 2. And 1 from 3 is what?
1.
2. Alright, so
Two.
our first term is 2. Follow?
Yes, sir.
Answer.
Yes, sir.
And then
Your answer spell good too, sir.
eh?
Your answer spell bad.
Oh. Hold on eh. How about that? Yeah, about that. Alright. So alright.
Sir, makes sense.
Alright, so to get so this would have been the first term, not true? So what you're gonna do is to do the same thing, but you're gonna have what? A2. So you replace n equals 2 and you work out that and you put down the answer right there. So that would have been the second term, then the third term, then the fourth term. And then you write it like this, you put an X comma with some dot here. That's what your answer is gonna be. So you don't when you finish with the first one, you don't do that. You follow? Because you're telling me that it's a finite sequence. Alright, so do you guys follow?
Yes, sir.
Alright, so
Yes, sir.
right, so that's question number
Yes,
1.
sir.
I am going to put some more questions. Oh boy, this thing is so small. Alright, let me see. Alright, forgive me. Let me just put in the other questions, the other recurrence equation. And then I'm gonna give you some time to finish them, alright? So this is I'm gonna scroll back. You can just write out the recurrence relation. So that one you kind of tricky, you know. You hear me? It's the last one here. It's a little bit tricky, but you know, just use your brain. Yeah.
Sir, question. What sequence will
No,
we will be using?
you're going to just write out the sequence. All right, you're not we're not identifying the sequence. You're just finding the terms. All right. All right. So let me explain.
Okay, sir.
A last one here. Let me explain the last one here. All right. So here what I want to know. So the last one here, no? If you notice, oh, I missed out something, you know. Okay, I missed out something. Alright, so this last one here. Where you notice, they actually give you first one, not true.
The answer.
They get the first one. Because guess what? The only way you can work this out is if you know the first one. Because look at the formula here. Remember now, n starts at what? Always starts at 1 or 2. So if you put 1 here, so 1 plus 1 will give you what? A2, right?
2.
So the formula here is actually A2, the second term. You follow? Right.
Yes, sir.
Then no, this is going to be
One again, please.
all right. All right, what's on? A1. All right, this is the recurrence relation, right? This is the recurrence relation. But they tell us a boy A1 is 4. All right, A1 is 4. Now, to work out the second one, this is what you're gonna do. Remember, now, n start at 1, so therefore, this is gonna be A1 plus 1, not true? Agree? Which is what? A2. So when it's n equals 1, and really A1 you find. Actually finding what? A2. Right, so A2 now I go equal to now a half a half what? A1. But what is A1?
4.
Right.
4.
So a half of 4 is what? 2. The second term is
Two.
actually what? 2. Alright? You guys see that? So when n equal to
Yes, sir.
when n is equal to 2 now, this is gonna be 2 plus 1, which is what? 3. So when it's n equal to, are really A3 are fine, not true? Alright, so what
Yes,
all right,
sir.
let me when n, you don't know what this thing, n equal to, when n equal to, you're gonna have A 2 plus 1, which is A what? A3.
A3.
What I know?
A3.
What I know? A3 now. To be equal to a half. Let me see who's so much hard. Ball.
Times 2.
All right. Why is it 2, Travis?
Sir, I said 2 because before remember that the first one says A1 equal 4. So remember, so after you work out everything and got A and got 2,
Right.
you say A2, A is 100. Sir, I don't really know how to put it, but I would say 2.
It's actually 2. And we're talking about this 2 here. Let me show you what. Remember, you know, when n equal 2, you know, n equal to 2, right? This is 2 plus 1, which is what? 3. And A3 is equal to a half AN. But what is AN? AN is 2. And what does AN2 mean? It means that the second term, whatever second term is equal to, you're going to use it. That's gonna give us 1. Why is that? Alright,
Yes, sir.
not because, and it's not because it's 2, you know.
Excuse me, sir. Second part, no, sir.
Alright. That's a question.
So when I get, when I
Alright,
get,
let me see if I can run through it one more time. Can run through it. All right, let's start over again. So basically, this is a recurrence relation, right? Recurrence relation. Tell you that A1 is equal to what? 4. So you just write on the 4. Alright? And now, start to work it out now, right? Alright, so when n is equal to 1, put 1 right there. So 1 plus 1 is what? 2. When n is equal to 1, we are trying to find what? A2. What does A2 represent? Second term. Alright? Let's follow the formula. We have A2 is equal to a half A. This should have been A1, not 2. That? So when this are 2, you know, when this are 2, this is
Yes,
2,
sir.
this is going to be what? 1. I think you probably see a little bit better now. In 4.
Sir. 4. I was about to say.
Okay, so what I know? So when n is equal to 1, the formula is what? 1 plus 1, which is what? A2. A2 is equal to a half A1 because n is still 1 here. So, and what is A1 equal to? 4. Half of 4 is what? 2. So A2 is actually equal to what? 2. Everybody get that? Then no,
Yes, sir.
when n is equal to 2 no, so we're going to have to know. N is equal to 2. We have A2 plus 1. What's 2 plus 1? 3. A3 is going to be equal to a half. Let me write this. A half
Times
A2. Not true. Yeah. Half times A2. Which is equal to a half times A2. What is A2? We just worked out A2 a while ago. A2 is what? 2.
2.
A half of 2 is what? 1.
1.
Because you get the 1,
Oh.
you know, that a
we
1.
let him ask.
Alright? So guess what? It's because of the 2 of them food, no? I wanted to do n equals
Yes, sir.
yes.
You know, give it to something up, sir. To work for do, sir.
Yeah, man, but I know, but I thought that this one, I knew that this one gonna give some problems, so I'm spending some time with this one.
Oh, alright.
Alright, so tell you what, it's because I spend so much time with this one, just do this one first, alright?
Alright, sir.
So, we're gonna start with n equals 3, 4, 5, and 6. Alright? So putty is supposed to have 4 more something like that. So. And remember that when you finish, put some dot the bracket, all right? Finish that for me. And I want you to do do this for me. So do this for me, all right? We have one. Do this one now. 1, 2, 3, 4. All right, I'm gonna give you. It's 130 now. So I'm gonna give you. All right. All of this. I'm going to step away. Almost done now, not true?
Yes, sir. We were waiting on you.
You serious? Why?
Finish.
But I was waiting.
All right. Still working. All right. Like done, you know. Like done, right? This one here at top. Travis, give me the first 4 terms in the sequence.
Sure, I got 1, 5, 9, 13.
Hmm?
Then
Right.
and then it continue, yeah.
All right, cool. What type of sequence is that? Finite. True. Also, divergent. True. Divergent. Also, do you think it's a arithmetic?
One, sir.
Yes, sir. I think it's
Right, arithmetic. Not true. Because guess what? Guess what? When you subtract 1 from 5, you get 4. 5 from 9, you get 4. 9 from 13, you get 4. Not true. You have a common difference. Not true. Right. So this one is also it's arithmetic.
Yes, sir. Yeah.
All right. Amari, you want to do the other one? This one? Right? Toya, you want to do this one here? Kamar, do you want to try one of them? One?
Sir, we Sir, memang kena miss.
All right. All right. Okay. All right. Yes.
Sir,
Hold on the Travis.
do you like if I give you them?
On the Travis. Evanik, You want to try that one? Keandra?
No, sir.
Jamelia? Okay. Otisa?
No, sir. Me no want try no.
Wait, asa na yan? Travis?
So I'm gonna try one.
Alright, Travis, let me get Zed for a try. Try it.
Yeah.
Zed, what time will you get?
I get 2, 1,
It's -1, you know.
-6. Oh yeah, -1, -6, -13, and -25.
Okay. Well, it says the first 4.
Now see it, sir.
Alright, so what about by the way, I'm trying to figure out what type of sequence is that. But I would say it's an infinite. It's convergent, not true? Smaller and
Convergent.
smaller, right? So it
Yes,
is
sir, because the number gets smaller and smaller.
infinite. It is converging, not true? Is it an arithmetic progression or is it arithmetic or is it a geometric? It's neither a geometric progression or arithmetic. Let's just leave it like that. All right, who wants to tackle this one? Travis,
Yes, sir.
want to tackle that one?
Yeah, I'll try. I got -5, then +5, then -5, then it just repeat
Right.
like yeah.
So
So I realize say it get smaller and then get bigger and then
right,
smaller.
right. So what type of sequence is that?
Divergent and convergent.
Excuse me, sir.
Yes.
So
Oh.
me get 4, then 6, then 4, then 6.
No, that's wrong.
Me know what me do. I add my addy and subtract. And at times.
All right, class. I
So that's the fine. I don't like finite because
go
you
on.
can't just stop.
No, it can go on. I would say it's infinite. Because so even though it doesn't stop, you know, it just keep up and on. So you wouldn't say convergent, divergent. What do you say? You just say use periodic. There's always a cycle. That's like-
I understand. It just repeats. It start from big and then small.
And are you guys following how we get these answers? Anybody
Yes,
have
sir.
Yes, sir.
Okay. So when I call nobody na ask no. I'm not sure no understand how we get them. All right. Let us look at this one that we're working on. So I need a response from 4 different persons. I didn't work out these, so I'm not sure what they are.
Sir, answer them supposed to get smaller and smaller, right?
I don't know. I don't work them out.
Well, no, yeah.
Okay, so give me what you have.
Sir, me know nothing.
Sir.
What you get a half?
Half.
Yes, sir.
Yes, sir. Half.
Hold on.
Quarter. Oh. Sir, we couldn't put them in a fraction or decimals.
Put them in a fraction.
Quarter. 1/8.
The last one.
1/16.
All right. Let us test. I'm going to test only one of them. I'm going to test this one here. No. Let me not do that. Let me test the one with the half. All right. So basically, when n is equal to what? 3, not true. So this is A1, A2, A3. So when n equal to 3, we're talking about A is actually A4, not true? A4 is equal to a half. It will be a half A3, not true? What is A3? A3 is 1. So it's actually a half multiplied by what? 1, which is equal to a half.
Half.
Which is correct. All right. So I'm assuming that the other 3s are correct. All right.
Yes, sir.
You realize that boy, to get the other one, you just multiply in a half times the previous one. You realize that? You realize that, guys? To get all right. Watch out.
Yes, sir.
A half of 4 is what? 2. Half of 2 is what? 1. Half of 1 is a half. Half of half is a quarter. Half of a quarter, 1/8, etc., etc. So it's actually correct. All right. This sequence is divergent, not true? Getting smaller, not true?
Yes, sir. Getting smaller or convergent? That.
Oh, sorry. Convergent. Right.
And sir, remember so that are infinite.
Right. It's also infinite. One more thing. Look at this. Is this a geometric sequence?
Yes, sir.
Right.
Yes,
It
sir.
is true because 2 divided by 4 gives a half. 1 divided by 2 gives you what? A half. A half divided by 1 gives you what? A half. So you notice we get a common ratio of what? Of a half. So R is equal to a half, which is what we call the common ratio. So therefore, it is a geometric sequence. All right, class? Any questions? All right. Everybody have this?
Yes, sir.
All right. Thank you. Okay, good. All right. So let's move on to one more question, and that question will take us out. No, is it on Monday? We're going to look at series. Monday, we're going to look at what we call series, which is different from a sequence. All right, so that's Monday's topic. You can probably Google it up, or review in the textbook I've sent. All right. Hopefully, we can finish series by next week Friday, and then the next week we will look at something called logarithms. All right, and then I think that will take us into the exams. All right. And if I have time, there is one little thing in the syllabus that it has to do really with CXE. It's a part of relations, functions, and graph. It's about gradient, length, midpoint, that kind of thing. So it's actually CXE, really, the CSEC syllabus. And if we can do all of that, we would have finished the module 1. All right, and then I'm gonna go through module 3 afterwards, and then the last thing we look at is module 2. Module 2 has to do with statistics. All right. Boy, this online thing is really slow. So, boy, it's
Sir, tell you.
But Travis, you know manage your school back Monday, man.
Just rope. No, it's true, sir.
Because if school back Monday, man, it's either face to face or online. So, that's another thing for you, not true? All right, so let's look at
challenging.
one more question, and we'll call it a day. One more. What am I doing? One more question. So this one requires for you to use a calculator. All right. So this question says, show that the sequence defined by featured in NPy is periodic. That's a question. Let me just bring it down to another page. So what we're going to do, solution, substitute n equals 1, 2, 3, 4, 5, etc. All right?
Sir,
Yes?
question. The pi symbol.
Mm-hmm.
Do we have to use the decimal for that or the fraction?
I'm going to come to that, yeah? I'm going to come to that. Everybody have a scientific calculator out? You guys have your scientific calculator?
Yes, sir.
All right. You know, apparently I can't find my one, so. All right. So we have 15 minutes. Let's see how fast we can go. All right. Okay, watch out now. So I'm gonna work out. It's just to show that this recurrence relationship is periodic. So we just substitute n equal 1. So in the formula we have a1 equals 3 cos my laptop is okay. It's reasonably good. 2/3. But this it's n, not true. So it's actually it's going to be times 1, not true? Because n is equal to 1, not true? And this n here is 1, right? Okay, this part here about pi. All right, watch out. Do you remember when you're doing CXC, or when when you were doing trigonometry in grade 10, grade 11? We always say make sure your scientific calculator is in degree mode. You remember who was saying that? Class?
Yes, sir.
Right. Okay, so you get to up now. Now pi just make a note here. Note in the degree mode of your scientific calculator, in the degree mode in scientific calculator, pi is equal to 180 degrees. All right.
Make sure the chicken is covered up the up and into the bone of the fried.
All right. So basically, so if your calculator is in the degree mode, right? Pi, you're gonna use pi as 180. However, Okay, guys. All right. So, however, if your scientific calculator is in radian mode, that means it has a little r at the top there. Pi is actually 3.14, right? And sometimes what they do, they put a little c there. You know, sometimes if it's a 3.14 c, it means that it is in the radian mode. All right. So in other words, if your calculator is in the degree mode, when you say pi, where you put 180 what degrees? You follow? If your
Yes, sir.
if your scientific calculator has the r on it, you're gonna put 3.14. I am suspecting that your calculator is in degree mode, so let's use 180. All right. All right. So do me a favor. I want you guys to punch in. Oh, by the way, tell you what. Best thing to do is to work out this first in the bracket. Work out in the bracket first and tell me what you get.
Sir, I got 120. The
Me
one,
too.
It's approximately 120. All right. What you're going to do is to find cos of 120. What's cos of 120?
negative 1.5.
No, not 1.5. 0.5.
Sir, calculator, tell me negative 1.5.
Serious? Cos 120?
Yes, sir.
Is that true, class? All right. Clear the calculator again. Let's put in cos 120. Do it again.
Same thing, sir.
Negative 0.5 me get.
Travis?
Yes, sir.
You know what I think probably have a tree. You probably work out the whole thing. Because when I work out the whole thing, I get negative 1.5. Final answer is negative 1. But if you go to work out cos, whatever you have in yourself, that's negative 0.5. All right.
Okay, sir, I make it negative 0.5. I told me did include the 3.
All right. Do me a favor. Write your answer as a fraction, but not as a decimal, please. So that's going to be true over 2, not true? Agree? Negative what? 3 over 2. That's how you go. So that would have been what? Your first term, not true? Do you want to work out the rest of me, please?
No, sir. Let's work it together.
Why? What time on? Alright, tell you what, let me just tell you the answers and I go and work it out. So that's all. Better?
Makes sense.
Because of time, you know. How you guys get over that? Alright, so if you were to do the other one, you actually same thing again. If you do the other one, you actually get the same thing again. Other one is actually 3. And that same thing. That. So what happened, you know? There's a lot of working out, you know. Cause guess what? When you get this one, you know, and then you get this one, and you get the 3, you have to continue working out and hope and pray you get what? Another 3. So when you finish that now, it will tell you that it is what? Periodic. Follow? Yeah, so you can't really do like this, boy, you know. Periodic, and then you reach a periodic. No, you'd have to get what? Another 3. It's a lot of work, so you'd have to find out what of them have to do. 1, 2, 4, 5, 6 of them. Right? Okay. Okay, so take it off. All right. Then when you finish, you guys finish?
No, sir.
No, sir.
Okay, I'm gonna add an next question, you see? Hence, find the values of A9 A17 and what is this? No. 28. So this is another part of the question, all right? Hence, you guys finish?
I am finished.
All right. Okay, so this one not gonna take long here. It's All right. Okay, so they can only ask. So they can only ask this question if the sequence is periodic. Okay? Make a note. So they kind of ask you a question like this because they're asking you what is what? A9, not true. So the value for A1 would have been this, not true. A2 is that, A3, but they want what? A9, A17, and A what? 28. Option 1 is actually work it out, but there's another way of working it out without using the formula. All right, and they will only ask you this question if the sequence is what? Periodic. So watch out carefully. Guys listening to me? All right, watch out.
Yes, sir.
Watch out. Look, I'm gonna show some magic
sir.
in the Friday here. Who wants some magic? All right.
I'll
Yes,
wait, sir. May I watch?
Every maths teacher is a magician, you know. You didn't know that? We make magic with numbers. All right, so watch out now. So another way of writing A9, you see? Tell me if this is true. Tell me this is true. A9 are the same thing as A6. A6 plus 3. Is that true? Yeah, man.
Yes, sir.
No, you see, because it's periodic. Like A6 and A3 would have been technically the same thing. Because it keeps on what? Repeating. In other words, the third term, all right, let me put it this way. Is 6 a multiple of 3? Yes. So whatever term is in the third position, if I get a multiple of that number, then it would have been the same number. You follow? All right. So the answer for this would have been 3.
Yes, sir.
So A9, so therefore, A9 is equal to 3. You guys following?
Yes, sir.
Yeah, man.
No, sir.
All right. The sequence is what? Periodic, not true? By the way, guys, look, the sequence is periodic, right? So, we notice the third term. What is this under the tree? That's A what? A what? A6, not true?
A6.
Look at this. What is A3? A3 term is what? 3.
A6.
And the A6 term, the sixth term, is actually what? The same 3. So we notice, because it is periodic, it keeps on, it's like a cycle. So if the third term is 3, if you get a multiple of 3, it will be the same term. So is 6 a multiple of 3? Yes.
Yes, sir.
Right. So
So 12, A12 would that be the same thing as 3?
it will
Yes, sir.
be the same thing. Therefore, A9 will be the same thing. Do you follow?
Yes, sir.
All right. Watch out now. is 17. No, A17. We could have said what plus what. You just find some numbers that you can work with. You'd say 50. You could have said 15 plus 2. What's 15 plus 2? 17, not true?
17.
20.
So what is A2?
Negative 3 over 2. Negative 3 over 2.
Negative 3 over 2. Alright? Well, this reasoning is probably going against when I talk about multiple, not true? But I guess if you find any combination, it will work. Alright? Because 2 is not really a multiple of 50, not true? Alright? And it's because it's 17 is a what? An odd number. It's a prime number. It's also what? An odd number, not true? Alright? So it's going to be kind of difficult to use that reason about multiple. Alright? But do you understand for the even for this number here when you can find a multiple? You could actually see it physically, you know, but it's not going to work for this one. The reasoning in terms of that. But to work it out, if you can find a number to add up to give you about 17, for example, a combination of 15, A15 and A2, that will actually give you the same answer, which is A2. And what is A2?
Negative 3 over 2.
Right.
Negative. Sir, I have a question. What if you use 9 plus 8? Would that be challenging?
No, you'd have to know one of them. You'd have to know one of these. You'd have to know A9 or A8. You follow? Yeah.
Yes, sir.
You'd have to know one of them.
So, sir, A17 and negative 3 over 2?
Yes, it will be negative 3 over 2.
Sir, that's supposed to be A17. You put A9.
I know, man. I know. It's because who wants to figure out wants to work with the other one? A28. What combination of number could you use here, so?
1 and 27, sir.
Yeah, you could do that. Yeah. By the way, this is our popular multiple choice question here. So you could actually say A is 17 plus 1. All right?
Sir, 27.
Sir, no.
Not 17.
27.
Oh. Right, that was an error. Okay. All right. So yeah. So you look for A1, and A1 is what? Negative what?
Negative 3 over 2.
All right. Okay, guys. So that's it for the class. All right.